All right, let's dive in. Today, we're going to unlock the secrets of encryption. We're breaking down the two core methods, symmetric and asymmetric, that pretty much power our entire secure digital world. So, have you ever really stopped to think about it? Every single time you type in a password or your credit card details, you're just trusting that it's being sent securely. But how? How in the world do you send a secret message to a server you've never met over the wide open internet without someone snooping on it? Well, that's the fundamental problem that encryption was born to solve. Okay, so the first and most straightforward solution to this is something called symmetric encryption. The idea is really simple, but as we're about to see, it comes with a pretty big catch. The concept here is just beautifully simple. Imagine you have a box with a unique lock. You write your secret message, put it in the box, and you lock it up. Now, to read it, your friend needs the exact same key that you used to lock it. One key. It both locks and unlocks. That's symmetric encryption in a nutshell. Now, the huge advantage of this one-key system is its speed. I mean, it is blazing fast and super efficient. This makes it perfect for encrypting massive amounts of data. We're talking about your entire hard drive, or streaming a huge video file. It's not a heavy lift for your computer. A perfect example is AES, the Advanced Encryption Standard, which is pretty much used everywhere. And here we go. This is the big catch. It's a huge one. If both you and your friend need a copy of the very same secret key, how do you get that key to them safely? You can't just attach it to an email, right? I mean, that's totally insecure. This is famously known as the key exchange problem, and it's a massive hurdle for symmetric encryption. So, to solve that really tricky key sharing problem, some brilliant minds came up with a truly elegant solution, asymmetric encryption. And this approach doesn't use one key, it uses two. So this system uses a special pair of keys. They're connected to each other through some pretty complex math, but they do completely different jobs. One is for locking and the other is for unlocking. Think of them as a match set, but they're absolutely not interchangeable. A fantastic way to think about this is like a personal mailbox. The mail slot, that's your public key. You can give out its location to literally everyone. Anybody in the world can come by and drop a letter in that slot, effectively locking it inside the box. But, and this is the important part, only you have the unique private key to actually open the mailbox and read what's inside. You share the public key with the world, but you guard that private key with your life. Now there's a trade-off. This two-key system is incredibly secure, for sure, but all that complex math behind it makes it much, much slower than symmetric encryption. You would never want to encrypt a huge file with it. It would take forever. Instead, its real power is in handling small but critically important pieces of data, like verifying someone's identity, or, you guessed it, securely exchanging another key. Okay, so we have one tool that's super fast but has a sharing problem, and we have another that's super secure for sharing but is kind of slow. This is where modern systems get really clever. They don't choose one over the other, they use both. Exactly. We have our toolkit laid out. Symmetric encryption is our race car. It's incredibly fast, built for performance. Asymmetric encryption, that's our armored truck. It's slow, sure, but it is the most secure way to transport something precious. And that right there is the million-dollar question. What if we use the slow, secure, armored truck not to move all our stuff, but for just one tiny job, to safely deliver the key to our race car? This is the fundamental idea behind almost all secure communication on the internet today. So here's how it all comes together. First, your computer takes the website's public key, that's the slow but secure armored truck, and it uses it to send just one thing, a brand new, single-use, symmetric key. Next, the website uses its secret private key to unlock that symmetric key. And boom, just like that, both you and the website share a secret key that was exchanged with perfect security. From that point on, you both use that fast, symmetric race car key to encrypt the rest of your conversation. You get the security of the armored truck and the speed of the race car. It is the absolute best of both worlds. And I want to be clear, this isn't just theory. This is the engine that runs the secure internet. You use this hybrid model dozens, maybe even hundreds of times a day, and you probably don't even realize it.
This little summary really puts it all into perspective. For that critical first handshake, where you need to securely exchange a key or verify an identity, you use the armored truck, asymmetric. But for all the heavy lifting, encrypting all the data that flows back and forth, you switch to the race car, symmetric. It's all about using the right tool for the job.
You know that little lock icon you see in your browser's address bar? Yep, that's an SSL/TLS handshake using this exact hybrid process. Secure messaging apps like Signal and WhatsApp, they use it to protect your chats. It's totally fundamental to how we log into services and move data around the web. It's everywhere.
So why did we go through all of this? Because understanding this trade-off, this partnership between these two tools, isn't just for academics. For anyone who designs, builds, or manages digital systems, this is a core principle you have to know.
Getting this right, knowing when to use which tool and how to combine them, is literally the difference between a secure application and a vulnerable one. It directly impacts the safety and privacy of all of your users' data, and it's a foundational piece of any responsible software architecture.
And that really brings us to our final and most crucial point. You can't just build something and then try to bolt security on at the end. It doesn't work. It has to be woven into the very fabric of a system, right from the beginning. Understanding these fundamental building blocks is step one. So the next time you see that little lock icon, you'll know the elegant dance of keys happening behind the scenes, all to keep you safe.